Assalamualaikum and have a good day, everybody. We continue our lesson on the final chapter of Physics TUF 1113 on magnetism. So there are four subchapters that we need to discuss over this chapter. So these are the subchapters for chapter 7, which number one is the magnets and magnetic field will be the first subchapter, and followed by the second subchapter, which is the magnetic force on electric current. Then followed by the third subchapter, which is magnetic force on moving charge particle. And finally, we will discuss about magnetic field due to a current carrying wire. So these are the four subchapters that we need to discuss. By the end of this chapter, students should be able to understand the concept of magnet and its field, solve problems on magnetic field due to current carrying wire, and solve problems of magnetic force on an electric current and moving charge particle. So we have three things to make sure that we know, we have the knowledge to solve this type of problem. So any magnet has two ends or faces called poles, where the magnetic field is strongest. So the two magnet ends is known as the north and also south pole. If a bar magnet is suspended, for example, in the compass, so the needle of the compass is actually a magnet. So one of the pole is known as north and south poles. So one pole of the magnet will always point towards the north. So if it is suspended, okay, at its center of gravity, so make sure that this is the center of its gravity so that the needle will move freely. So it will follow, it will point to the following the direction of the poles of the magnetic field of the planet Earth. So the pole of freely suspended magnet that point towards north, known as north pole of the magnet. So the other pole point towards south, known as the south pole. So magnet is bar magnet generally is looked like this. One of its end known as south pole and the other end known as north pole. It is familiar observation that when two magnets are brought near one another, each exert force on the other. For example, okay, this is the general knowledge. Like poles repel, unlike poles attract. So if we have two bar magnet, okay, the north pole, we bring them together, they will repel each other. Same goes for the south poles. But unlike poles, for example, if one of the end is south pole, the other one is north pole, they will attract each other. Remember this. This looks like simple, but we tends to forget at certain cases. We will look at the cases later. So the force can be either attractive and repulsive, and can be felt when the magnets don't touch. The force exists, even though we cannot see the force. So if your bar magnet is cut into half, if you cut the bar magnet into half, two new magnets are produced. No magnetic monopole has ever been observed. If we try to separate between the south pole and north pole separately, we cannot do that. No theoretician or no experimental physicist could create a monopole. For example, we want, just like the electrical charges, we could separate between the positive and negative charges, but in magnets we cannot do that. Okay, no monopole has ever been observed. If the cutting operation is repeated, we cut and cut and cut and cut until they reach nanoscale. They still are producing a nanoscale magnet with north and south pole, just like that, until we cut them into one atom. Now one atom, actually one atom also, they have north and south pole. Still they have, because they have the electron spin and all that, so they still have north and south pole. They cannot be separated. The magnetic field and the current field is different. Now, do not confuse with magnetic poles and electrical charges. Charges can be easily isolated. We could isolate the positive and negative charges, but an isolated single magnetic pole has never been observed. It cannot be isolated. So in previous chapter, we used the concept of an electric field line. In previous chapter, in electric, in chapter 7, we could use the similar concept of electric field line. So in similar way, we can picture magnetic field surrounding a magnet using magnetic field line. How are they look like? Okay, later we look at them. So the magnetic field lines are drawn so that the direction of magnetic field is tangent to a field line at any point. What does it mean by tangent? Okay, you could Google the meaning of tangent versus perpendicular. Let us see if I have opened any. Yes. If you look at this website, okay, you could check the URL given in my PowerPoint slide. Okay, there is an URL. There is a URL over here. You could right click and you could click control and click this the word Google over here, and it will direct you to this portal. What does it mean by tangent? We have the tendency to confuse with tangent with normal, but a tangent to a curve is a line that touches the curve at one point and has the same slope as the curve at that point. So if this is the curve, tangent is the location at any point of the curve, for example, this point, which has the same slope as the curve. For example, like this. This one is tangent to this line. So in our the direction of magnetic field is tangent to a field line. What does it mean? It means that if we have, let's say, if we have a field line like this, okay, if we put a compass over here, the compass will follow the direction of the magnetic field. This is tangent. It follow the curve. It follow the apa ni? Yeah, it follow the direction of the electric field line, magnetic field line. This is tangent. If normal like this is normal. The compass doesn't show the normal direction to the electric to the magnetic field line. It follow the tangent of the magnetic field line. So this is compass, direction of magnetic field. Okay. So the number of line is proportional to the strength of the field, similar to that of the electric field line. The more the magnetic field line means that the strength of the magnetic field is higher. So the direction of magnetic field, at given point can be defined as direction on north pole of compass needle point. Remember that. Now let's see. Seems like we understand, but let's see first, right? So let's say this is a bar magnet with north pole and south pole. How do we know that? We could use the compass. So if we scattered a very fine particle of iron filling, tiny magnets, it will reveal the magnetic field. Okay, we could see the magnetic field like this. Nampak ni? The shape of magnetic field. The direction of magnetic field can be shown. Okay, this is the magnetic field. We could see that these are reals. They are not imaginary. But which one is, how do we know which one is south pole, which one is north pole? We put the compass. And how are we going to do that? So we look at the direction of the compass. Remember, okay, look at this diagram. The magnetic field line go out from the north pole and comes in right into the South Pole. Okay, keluar daripada North Pole, masuk kepada South Pole. Kena ingat ni. So, if we put another magnet over here. Okay, now, this one should comes in. Okay. This one should comes in. This one should comes out. So what pole is this? What pole will receive a magnetic field? This will be the south pole of the magnet. This is a bar magnet. This is a bar magnet. Bar magnet. This will be the north pole of bar magnet. So remember, a compass is actually a suspended bar magnet. Like this. So the north pole. See, the compass will show north pole. So if you look at this compass, this is its north pole. Ni nampak ni. The needle is like this. This north, this is south. So the north pole of a compass is actually showing the direction towards the south pole, the magnetic south pole of this bigger bar magnet. Pak, dia mesti keluar daripada north kat sini kan. Ini bar yang magnet yang besar ni, bar magnet yang besar ni. Dia keluar bar magnetic field line daripada north ni, dia akan masuk kepada south pole magnet bar di dalam kompas, dan dia akan keluar daripada north pole magnet bar dalam kompas, dia akan masuk kepada south pole semula bar magnet yang besar. Tadi kamu kata faham kan? Semua orang faham yang ini. Keluar north, masuk south. Semua faham. Sekarang ni saya nak minta bayangkan ada kompas. Kompas ni kita boleh simplify dengan satu bar magnet kat sini. Dan kompas ni kita kena tahu pole dia yang mana satu. Okey, kena tengok balik. Dia akan align dengan yang ni. Okay, dia akan align dengan yang magnetic field line daripada magnet bar yang besar. Ini keluar. Dia akan masuk dalam bar magnet. Dia akan keluar ke sini daripada bar magnet tersebut. Magnet yang magnetic field yang masuk ke dalam bar magnet kompas ni, hujung ini dia akan jadi south pole. Mestilah south pole kan? Kalau tak, dia akan menolak. South pole ni akan tertolak ke sana kalau tak. Tapi masalahnya, kalau kita letak north pole kat sini, north pole kompas kat sini, dia still akan tertolak ke sana. Dia akan align menjadi macam ni. Dia automatic. Kan kompas kan bar magnet dia akan suspended. Jadi dia akan align sendiri, dia akan pusing sendiri. Kamu tak boleh paksa north pole kompas ni mengalir ke sini. Nampak? Dah jadi bahasa Melayu semua dah. Tak kisahlah, campurlah. Janji faham kan? Jadi magnetic field ni dia akan magnetic pole untuk bar magnet dia akan follow, dia akan ikut magnetic field line bagi bar magnet yang besar ni. Sebab yang ni suspended, yang ni fix. Yang ni fix. Yang bar magnet ni dekat kompas dia suspended, dia akan berputar, dia akan ikut. Jadi south pole dia akan ke sini, north pole akan sini. Jadinya maksudnya adalah dalam kompas kita ni, saya tunjuk dulu lah. Okay, tak apa, saya baca dulu. So the line always point out from the north pole and towards the south pole of a magnet. Ni, saya terangkan tadi kan, dia akan keluar sini, dia akan masuk sini. Ini tak boleh ubah dah. North keluar, south masuk. Magnetic field line always form closed loop. Make sure, ni pun closed loop sebenarnya. Tapi sebab dia jauh sangat, kita tak lukis lah. Nampak ni pun closed loop sebenarnya. Ini dia. The earth magnetic field. Okay, the earth magnetic field. Nampak ni. This is the rotation axis. This is the north geographic pole. Geographic pole and magnetic pole, they are different. Do not get confused. Okay. So this is the north geographic pole, which is known as true north of the Earth. This is the south geographic pole. But if we study the planet Earth in terms of magnetic poles, they are different. So the magnetic pole is a little bit tilted like this. And the nearby the north geographic pole is actually the true magnetic pole, the south magnetic pole of the planet Earth. And nearby the south geographic pole is the magnetic pole, the north magnetic pole of the Earth. Dia terbalik. Kalau magnetic pole dia akan terbalik. Yang dekat north geographic pole tu sebenarnya dia adalah south magnetic pole. Yang dekat south geographic pole pula dia sebenarnya adalah north magnetic pole. So the compass, our compass is suspended. The magnetic bar of the compass is suspended such that it will move freely. So it will follow the direction of the Earth magnetic pole. See, Earth magnetic pole macam ni. Magnetic field line dia akan keluar daripada north, dia akan masuk ke south pole. Ini pula kita ada bar magnet untuk kompas kita. Daripada north, dia akan masuk ke south magnetic pole kompas kita. Dia akan keluar daripada north magnetic pole kompas kita, dia akan masuk balik ke south pole magnetic pole of Earth. Jadinya magnet kompas kita menunjukkan ke arah north. North apa? Bukan north magnetic pole. Dia akan tunjuk the true north of geographic pole. Kat situ. Dia still kompas kita akan tunjuk ke arah utara. Utara apa? Utara geografi bumi, bukan utara magnetic field bumi, tak. Dia akan menunjuk magnetic field yang selatan untuk bumi, tetapi geographic pole masih adalah north. Jadi kompas kita adalah betul dia tunjuk north. Memang akan tunjuk north, tapi north apa? North geographic pole, bukan north magnetic pole. North magnetic pole bumi dia akan tunjuk ke arah selatan. Itu salah silah apa kompas kita baca sebenarnya. Dia akan menunjukkan ke arah utara geographic pole bumi. Dan pada masa sama, dia menunjukkan ke arah selatan magnetic pole bumi. Menggunakan konsep ni lah. Yang konsep paling simple iaitu kita punya medan magnet. Faham medan magnet ni, kamu boleh terangkan benda ni. Right. Okay, that is all for this slide. So I will continue our recording slide in shortly.